Good evening, folks. Welcome to our last night here before the final. I promise the final will be posted, will appear for you tomorrow morning, and then you'll have throughout the day to do it. You'll turn it in by Friday evening, as we have done with the previous exams. I want to start by doing this example. But then I will open it up, as I have been the past few nights, to questions of any sort that any of you have, and I will do my best to answer them for you. So let's do this as a quotient rule question. This is one you could do as a product rule question, but we can always use more practice with the quotient rule. So here is our A, and B prime. So we can put that together to get our G prime of X, A prime B minus AB prime. All right, and let's go ahead and simplify this. Over the powers multiply, and I can factor an x squared out of the numerator. And now, in fact, I can cancel the x squared with 2 of the x's in the denominator, and so this will become 1 over 3 log x over x to the 4th. Okay, so that is my G prime, but the question actually asks for G prime of e to the minus 4th, so let's do that. So 1 minus 3 times the natural log of e to the minus 4. The natural log of e to the minus 4th is minus 4. So this numerator here is 13. And then this is divided by e to the minus 16th. But an e to the minus 16th in the denominator would just be an e to the 16th in the numerator. So that is our answer. I'll note, by the way, last night in class I did a lot of examples just more questions from old finals. So if you are looking for even more examples of questions you can do with solutions from me, you can look at the video from last night. But with that, let me open it up and see if anyone has any questions about anything from the sample exams or the past tests or any topics in particular that people want to go over. 13E. Sure. Okay, so we have here a function 2x over x minus 3. And we have this graph to go with it. So what we have here, if I go ahead and highlight these things, I'll put that one in red and this one in blue. I can find the red line first. The red line is the tangent line to the graph at the point 1 minus 1. So I know how to go about that. So again, I need to use the quotient rule. Divided by x minus 3 squared, which is going to be 2x minus 2x. So all that's going to be left here is a minus 6 divided by x minus 3 squared. Okay. So the red slope then is f prime of 1, which as it happens will be minus 6 divided by 4, which is minus 3 halves. Okay. That is the slope of the red line here. Okay. But actually, if you look, I'm really more interested in the blue line, which as it happens is perpendicular to the red line. And so I know its slope too. Namely, its slope is 2/3. Okay. And where did that 2/3 come from? It's just the negative reciprocal of the slope of the red line. Okay, so now I have the slope of the blue line, and I know the line passes through the point 1 minus 1, so I can go ahead and find its equation. So it's going to look like y equals 2/3 x plus b, but I've got minus 1 is 2/3 plus b, so b is minus 5/3. And so that means the equation of the blue line is in fact y equals 2/3 x plus 5/3. Although it might occur to you that I could write this in a slightly nicer looking way, namely I could write this as 2x plus 5 divided by 3. Okay, now what do I want to know? I want to know when this line intersects the original graph itself. So to do that, I need to set this equation equal to the original equation. So that is, I can take 2x plus 5 over 3 and set that equal to 2x over x minus 3. And I can solve that equation. Isn't it minus 5/3? Yes, it is minus 5/3. Thank you for pointing that out before I made it all the way to the end and realized that I had miscopied my own writing. That will make life much easier. I better actually change it in the one place that matters. Okay, so that's going to give me 6x equals 2x minus 5 times x minus 3. So let's see, that is 2x squared. Let's see, minus 6x minus 5x, so minus 11x, plus 15. Okay, and so if I pull this 6 over here, this will be 0 equals 2x squared minus 17x plus 15. And if I look at that, that will factor as x minus 1 times 2x minus 15. So the x equals 1 point, that's that point that we started at. So no use looking at that one. This has got to be the other point. And so that is the point with x being 15 halves. Okay, and so that's the x coordinate. To get the y coordinate, I can just plug 15 halves in for x in either the original equation or the equation of the tangent line, whichever you prefer. I'll plug it into the equation for the tangent line, where it will give me 15 minus 5 over 3, or 10 thirds. So the coordinates of the point are 15 halves, 10 thirds. Any questions about that? Okay, I'll go ahead and pull up number 4. And so we've got 2 points here. One is something, comma 4, and one is 4, comma something. And these points are living on the graph of f of x equals x squared. So these are both input-output pairs. So here the input is 4, so the output is 16. That is just f of 4. Here the output is 4, so the input is what I put into x squared to get out 4, which at first you might think 2, except I see where it is, so it's got to actually be that this point is minus 2. Okay. Again, all that really happened there is you said, okay, x squared is 4, so x is plus 2, or x is minus 2, but the right one of those was minus 2 because of where it was in the graph. So then we've got this line drawn in, and some point over down here. And so we want to find now this point. And so the key piece here is these two lines are parallel, so they have the same slope. And that slope that they both have is 16 minus 4 over 4 minus minus 2, which is 2. And so this line in particular also has slope 2, but this is the tangent line at the point I want. So I'm really asking here, where is the slope of the tangent line 2, which means I want to take the derivative of f, and I want to set that equal to 2, which I can solve, and it'll give me x equals 1. And then the matching y coordinate here will be the output that matches 1, which in this case happens to be 1. So the answer is 1, 1. Any other questions I can help people with or talk about? One 1.1. On exam E. Gotcha. 1.1. I can do all those things for you. Okay, 1.1 gives us f of x is 2x minus 1 times 2x plus 3 times e to the x. And we want f prime of 2. So first things first, as it's currently written, there are 3 terms in this product. I don't really want to deal with a triple product rule. So rather than doing that, I'm going to multiply these 2 things together first. I'm just going to multiply the 2 binomials here, which will give me 4x squared plus 6x minus 2x. So that'll be plus 4x minus 3 times e to the x. And having done that, it's now set up for the product rule much more nicely. So I can take the first term here being this. Okay, so then f prime of x will work out to be 8x plus 4 times e to the x plus 4x squared plus 4x minus 3 times e to the x. Okay, so at the end of the day, that will be e to the x times 4x squared plus 12x plus 1. And so f prime of 2 will be e squared times 16 plus 24 plus 1, which is 41 e squared. Okay, let's do 9 next. Okay, so this one asks us to find the coordinates of the whole. Remember, wholes always come from these 0 over 0 things. Okay. So I'm looking for an x coordinate that makes both the numerator and denominator 0. Okay. So let's start with when the denominator is 0. That happens when x is 3 or when x is minus 2. And I can just plug both of these into the numerator. If I plug minus 2 into the numerator, it is in fact undefined, so that's not the one I'm looking for. But if I plug 3 into the numerator, I get the square root of 6 plus 3 minus 3, which in fact is 0. So f of 3 really is, quote, 0 over 0. Which is where the hole in my graph is coming from. So the x-coordinate of that hole is 3, and the y-coordinate we get by evaluating the limit. Because remember, limits are our tool for handling this 0 over 0 thing. So the y-coordinate I'm looking for is going to be the limit as x goes to 3 of this whole thing. And to handle these limits with square roots in them, we multiply by the conjugate. Okay, which will end up being 2x plus 3 minus 9. Sorry, there's a limit in front of this. Divided by x times x squared minus x minus 6 times, and then this square root business. So the numerator here will factor as 2 times x minus 3. And the denominator will factor, I actually already factored that, as x minus 3 times x plus 2 times this piece with the square root. Okay. And that gets me to the point where these x minus 3's cancel, which is what I wanted. So that clears out my 0 over 0, because I cancel the 0 from the numerator and from the denominator, basically. And so now this is 2 over 5 times 6, which, as it happens, is 1/15. Okay. I'll leave a second for people to catch up and ask if they have further questions about this, and then I will go on to 11, seems to be the next question people have. Okay, so $11 comes with a graph. Graph looks like that. So first question is to use the graph to approximate f prime of 3. To do that, you want to draw in the tangent line and then estimate its slope. So I estimated that the original point was approximately 3 and let's see, this is 4 plus a third, so that would be 13 thirds. That was just my approximation. And then looking at where this dashed line lands, at least when I drew it, it landed pretty close to here. So that is, it landed at about 2, 3. And so then I would get that my slope here would be 13 over 3 minus 3 divided by 3 minus 2, which, as it happens, would be 4 thirds. Okay, so that was my approximation of the derivative. You might end up a little higher or a little lower, depending on exactly how your line ends up and how you estimate the places that it goes. But you should not be wildly off from this. Uh, okay. The next piece asks about the limit as x goes to 1 of f of x. Okay. This is actually the mirror to the question we just did, where I have a hole in the graph, and the limit is going to tell me the y-coordinate of the hole in the graph. Namely, the limit as x goes to 1, in this case, is going to be 3. Okay. Note that is in contrast with the fact that f of 1 is actually 1. Okay. So be careful not to confuse those two facts. The next part asks about the limit as x goes to 2 from the right. Okay. That is x going to an input of 2 from this side, which is going to be going to a y value of minus infinity, because that's a vertical asymptote right there, which is a preview of the next question. This function has two vertical asymptotes. Namely one that we just discovered at 2, but also one at 6. And as it would happen, there are no horizontal asymptotes shown in this graph. And then the last piece asks for a critical point. There are actually 3 critical points to choose from in this picture. So you could choose this one, or that one. These are the 3 spots where the tangent line is horizontal. So you could pick -2, 1, you could pick -3, -1, or you could pick 4, 4 2/3. Questions about that, or further questions? (12.4). 12.4 asks, based on this graph of the derivative, where is f of x increasing the fastest? And that is really a question of where the derivative is biggest, because the derivative is telling you how fast the function's changing. So if you look at this, there is one point where the derivative is biggest, namely this one. So the place where the input where f of x is increasing the fastest is this one, which is about 5.6, 5.7, somewhere in that area. Other questions? Let's see. Let me go ahead and put up a sample question. I will let you work on this practice question. If more questions show up... Oh, I have another question. 14E is the next question. I will put up a practice question after this one. So 14E gives us this salt problem. So we have this function here where the input is tons of salt. And the output is the cost to make that much salt. And so our function here is given by this. So our derivative here is going to be this. And so C prime of 50 is going to work out to be, well, what's 40% of 50? That would be 20, so this will be 70. And C prime of 100, that'll be 90. Okay. And I'd always write the units on these. So this is dollars per ton. This is this. Okay. Again, I know that because it's the units of the output over the units of the input. And so what is this telling us? This is really telling us that the 50th ton of salt we extract is costing us $70. And then the other part is telling us the 100th costs $90. So what we're really learning here from a business point of view is that as I extract more salt, extracting more salt is getting more expensive. The hundredth ton of salt that we got cost us more than the 50th. Now, whether it's a good idea or not to extract this many tons of salt, we don't know because we don't have information about how much we're selling the salt for. But we definitely have to be careful because we cannot extract too much because it will become too expensive. Any questions about that or other questions we want to talk about? I will put up a practice question. I will give you a couple minutes to think about this. Okay, let's come back and make sure we're on the same page about how to do this kind of question. So the key thing here to notice is that this dashed line, this is the tangent line at the origin. So I should be able to find that. To do that, I'm going to need the derivative, of course. So f prime here will work out to be x squared minus 2x plus 2 minus 2x squared plus 2x. All divided by x squared minus 2x plus 2 squared. So this will be minus x squared minus 2x plus 2x. That's 0. So then just plus 2. All divided by this. Okay. Now I have to remember what it was I actually wanted. And what I actually wanted was the equation of the tangent line at 0, 0. So f prime of 0 is my slope. And that happens to be 2 over 4, which is the same thing as a half. And so that actually completely tells me the equation of the tangent line here. Namely, it is just y equals 1/2 x. And I know that because the y-intercept of this line is the origin. So I don't have to worry about the plus b part. So then I want to set this equal to the equation of the function. So x over 2 equals x over x squared minus 2x plus 2. When I cross multiply, will look like this. I can go ahead and subtract the 2x over. Like that. And I can factor out an x squared. And that will tell me that I'm either looking for x equals 0 or x equals 2. But x equals 0 is this point that I started at, so it's definitely not the one I'm looking for. So I'm looking for x equals 2. And so that means the coordinates of this point are 2, comma, and then f of 2. And f of 2 is 1. I'll go ahead and put up a derivative interpretation question, since people seem to always enjoy asking about those. I'll give you a couple minutes to look at that. Alrighty. So let's calculate p prime here. That should not be too bad. So p prime will be 1,000 minus 8q. So I will do 5e after this. Sorry, I'll do 7e after this, and 5e. So p prime of 100 is then going to be 200. And note the units of this function. The input is in widgets, and the output is in dollars. So this is dollars per widget. And so what does this mean? This means that the 100th widget we sell is really getting us $200 of extra profit. The next question asks, okay, well, then how many widgets should they make? So you can pause for a minute and think, was 100 too many widgets, too few widgets, or just the right number of widgets? But making the 100th widget made us money. And so really, the way we want to think about this is we want to keep making widgets until we stop making money. And so really what we're solving here is we're really solving the equation derivative of profit equals 0. So that will give me Q equals 1,000 over 8, which will give me 125. And this is in widgets. And so making 125 widgets will make us the most possible profit. Okay, I've gotten a couple more requests. Let's look at 7e. We want the min and max on 2 to 7. I think the first thing we have to think to do here is we probably want to combine these two fractions. Because I want to take the derivative, and I'm going to have an easier time if I'm taking the derivative of one fraction than if I'm taking the derivative of two fractions. So this will be minus 3x minus 4 over, and I'm going to go ahead and spell this out, x squared minus 9x plus 8. Okay. The only reason I'm foiling out the denominator is because I'm about to take a derivative using the quotient rule, and that's always a step we have to do in order to take the derivative of something if it's multiplied out like this. Okay, so a prime here is minus 3. B prime is 2x minus 9. And so then our derivative here is going to work out to be minus 3 times this minus minus 3x minus 4 times 2x minus 9 all over this mess. Okay. I really only need the numerator here. So it's going to be minus 3x squared plus 27x minus 24. And then it is going to be plus 6x squared. Let's see, that is a minus 27x plus 8x. Will be a minus 19x. And 4 times minus 9 will be minus 36. So this will work out to be 3x squared. Let's see, 28x minus 19x, that's a plus 8x. Minus 24 minus 36, that's minus 60. Okay, and then we have to decide how to factor this. See, and you've got to run through a few options. Let's see, but then you come up with 3x minus 10 plus 6. Is this right? Let's see, 3x times 6 be 18x minus 10x would be plus 8x. Okay. So that gives me my two critical numbers, x equals minus 6 and x equals 10/3. But notice this one is out of the interval. Okay. So I really only have to look at 10/3 and then the two endpoints. So I need to figure out what f of 2 is, what f of 10/3 is, and what f of 7 is. Okay, so f of 2, keeping in mind this is our equation for f. F of 2, let's see, that'll be minus 6 minus 4, that's minus 10, divided by 4 minus 18 is minus 14, plus 6 plus 8, how about 14 plus 8, will be minus 6. Okay, so this should be 5/3. F of 10/3 will be minus 14 divided by, and now I've got to figure out the denominator here, which is going to be a bit messy, 100/9. Minus 30 plus 8. Okay, so this is minus 14 divided by, okay, and so if I put minus 22 over 9, this will be minus 198. I believe. So this will be minus 14 over minus 98 over 9. So this becomes, let's see, this is going to become 9 times 14 over 98. I can cross out the 2 from here, which will leave me with 7, and the 2 from here will leave me with 59. So this is 63/59. If I did that right. That is not what I got when I did this before. I may have screwed that up. But anyway, whatever this number works out to be. You probably do not want to watch me do that again to figure out where I made the mistake. And then f of 7 is going to be minus 21 minus 4 over, and then 49 minus 63 plus 8, which is minus 25 over, let's see, that's 57, minus 6. Should be 25/6. Okay. Anywho, having somehow... Oh! I see what I did wrong. Okay. Half of 98 is not 59. Half of 98 is 49. So this was... Sorry. So this was 9 times 7 over 49, which is 7 times 7. Okay. So in fact, actually f of 10/3 was 9/7. Sorry about that. Okay, so this is by far the biggest. And then this one is the smallest. Okay. 5E. E5. Okay, so we're asked to find these 2 points in the graph of this function. So we have to identify what sorts of points these are first. So this one here is an X-intercept. And this one here is a critical point. I know this one's an X-intercept because it's on the X-axis. So I actually know... I don't know what the x-coordinate is, but I know the y-coordinate is 0 before I even do anything. And this is a point where the derivative is 0. It's got that horizontal tangent line like we've been talking about for a good chunk of the semester. So let's first find the x-intercept. So the x-intercept is going to happen when the function is equal to 0. That is when 2x minus 5 is equal to 0. To say when 2x is 5, to say when x is 5 halves. So the x-int here is 5 halves, comma 0. Going all the way back to week 1. The critical point, we're going to need the derivative. Okay, so here a is going to be 2x minus 5. B is going to be x squared plus 6x plus 9. I went ahead and FOILed out the denominator there before we take the derivative, just to make sure that I know how to take the derivative. Okay, so the derivative here is going to work out to be 2x squared plus 12x plus 18 minus 2x minus 5 times 2x plus 6, all divided by x squared plus 6x plus 9 squared. Okay, so I'm going to grab just the numerator here, which is going to be 2x squared plus 12x plus 18 minus 4x squared plus 2x minus 30. This will be minus 2x squared plus 10x plus 48. And I can divide everything through by minus 2. Okay, and for once, this actually factors nicely. So I am going to get x plus 3 times x minus 8. Okay, which is going to give me that x is minus 3 or x is 8. But note, the critical point in question definitely has a positive x coordinate. So the critical point definitely has this x equals 8, 1. Okay? And so the critical point is then going to be 8, comma, and then I've got to plug 8 into the original function, which is going to give me 11 divided by 121. Which, as it happens, is 8, 1/11. Alrighty, any last-minute questions before we wrap up? Alrighty. Well, thank you all for making this fun for me, even though the format is, to say the least, unusual. I hope you all enjoyed this on some level, and I hope you all have a safe trip home. Good luck on other finals. Oh, I see I have a request for 10. I will do 10. Let's see. 10 asks to find the derivative of f of x is x squared over 2x plus 1 using the limit definition. So we're going to have to write down our 2 points. Oops. Okay, so we want to calculate the average rate of change here. I'm going to go ahead and put the 1 over h in front to make my life easier. And I'm going to have to put this over a common denominator. Okay, so this is going to be x squared plus 2xh plus h squared times 2x plus 1 minus 2x cubed minus 2x squared h minus x squared. Okay. So this, when I multiply it out, it's going to be 2x cubed plus 4x squared h plus 2xh squared plus x squared plus 2xh plus h squared. And I'm going to just extend this numerator over down here. Minus 2x cubed minus 2x squared h minus x squared. Close parenthesis. So let's go ahead and find stuff that cancels and hope there's a lot. So there's a 2x cubed and a minus 2x cubed. There's an x squared and a minus x squared. There is... That might be it. So I go ahead and write this down. Next line. H times 2x plus 2h plus 1. 2x plus 1. What's going to be left in the numerator? So these two will combine and leave me with a 2x squared h. That will be a 2xh squared. So I've taken care of that term, and that term. Plus 2xh plus h squared. Okay. And now I can factor an h out of the numerator. Which goes like that. And those cancel, which is what we hoped for. And so now, when I go to calculate the derivative, it is the limit as h goes to 0 of the average rate of change, that is, of this thing. And that limit is going to be 2x squared plus 2x divided by 2x plus 1 times 2x plus 1. Or if you want, this is 2x squared plus 2x divided by 2x plus 1 squared. Alrighty. Let's wrap it up there for tonight. Have a safe trip home. I will see you all around campus, hopefully when campus is a nicer place to be in January. Until then, have a good break.